In this video, we're going to look at a couple of basic problems just using our volume formulas to find the volume of some figures. So for our first one, we'll just call this our first example here. We'll say example 1. We're going to take a look at a cylinder. So cylinders, you can kind of do rough sketches of these things. We're not going to go for perfect artistic shapes here. Let's assume that this is a basic right cylinder. Let's give it a height of 10 inches, and let's give it a radius. Let's do the radius down here. Give it a radius of 3 inches. Now it's kind of hard to read that inch down there, but it's 3 inches. So a radius of 3 inches, a height of 10 inches. What I like about volume problems is that they're essentially one of the easiest things that you could probably work with because they're mostly just plugging values into a formula. And I say that because there's no manipulation that you have to do with this type of problem. When I work this problem out, all I'm going to do is say, well, look, I know the radius is 3 inches, I know the height is 10 inches, and then I have two options here. My preference is to give an exact answer. So what I mean by that is that 3 squared is 9, times 10 would make 90. This whole chunk of numbers here is 90 times pi. So for me, I'm perfectly okay saying, oh, my volume is 90 pi cubic inches. Now this is read as cubic inches. Do be careful about that. But this would be what I refer to as an exact answer. The reason for that is there's no rounding involved. Pi is this irrational number. It has this infinite decimal that kind of makes things a little messy. So by saying 90 pi, I have a very exact number. As opposed to, if I go to the calculator here, I'm going to just type in 90 pi, and we're going to see that that's 282.7433388. It keeps going and comes with all this weird stuff. Even if this is an exact decimal, that's just messy. Now, I tend to see most people, if they ask you to do this, seem to like to round to 2 decimal places. So here we'd have 0.74, just pointing out here that for rounding purposes, this 4 does not change because this 3 is less than 5. So, and I suppose appropriately, this should be approximately, since it is a rounded value, so let's fix that. And it would still be inches cubed. So we do want to make sure, actually I should say cubic inches to be more exact. So either one of these would be acceptable answers for the most part. But this right here, this is my preferred way of doing things. Now I know some programs, I know IXL will actually ask you to use pi as exactly 3.14. So let's just take a look at that real fast. Notice that if you were to do this and accidentally plug in the original answer, in IXL it would actually mark this one wrong, even though this one's actually more correct, because they round pi to 3.14. So be careful if you do any kind of practice online. Some sites will require that you use 3.14. That will give you answers that are a little different. Let's take a look at another one then. So we can do this. One of the only differences I see with cylinder problems is sometimes they won't give you a figure. They'll use just words. We'll say find the volume of a cylinder. They do need to specify that. When I start seeing radius involved, it could be a sphere. We're going to say with a height equal to 13 feet and a diameter of 30 feet. Only reason I want to look at one like this is I feel that sometimes people will look at a problem like this and it'll be so straightforward, so basic in the sense that they know they're just plugging in numbers that they'll get ahead of themselves. They'll go right to a calculator and they'll plug in 30 squared, they'll plug in the 13 and the pi, and they will get it wrong because they didn't read the key word of the problem. It's very important to me that we look at each word in the problem very carefully because a diameter is not a radius. In fact, a diameter is twice your radius. If you don't remember this, diameter equals 2 times your radius. It's very important to know. If you remember that, then in this case, we would take half of this 30. Our radius would actually be 15. Once you're over that first hurdle, this is not a problem at all. Because now we do pi times 15 squared times the 13 for the height and we can come up with our volume very simply. So let's go ahead and drop this into a calculator very fast. We have 15 squared times 13 times pi, and I'm going to go ahead and just do a rounded value here. So let's go ahead and put an approximate instead of an equal sign. We're seeing 9,189.16. Now notice the 5 this time is being bumped up to a 6 because my 8 is larger than 5, or greater than or equal to 5. And this would be cubic feet, so I need to put that little indicator there as well. You can't talk about volume without being clear on the units, unless they choose not to provide you with units to work with. So let's do one or two more of these. Let's do two more, and then we'll call it there. So let's do one where we do the volume of a triangular prism, and then we'll take a look at a sphere. That way we have a couple of different examples. So let's go ahead and say that we have a triangular prism that looks something like this. And they're going to give us the height of this little triangle here as 2. We'll need a little right angle here. They're going to give us this base of that triangle to be 4. And then the depth or the height of the prism itself, however you want to look at that, is going to be this length of 8. And this is what I mean about not necessarily being given units. In this problem, I have not been provided with any units to work with, so I'm not going to worry about what kind of cubic units there might be. I'm just going to focus on the problem at hand. And we said that for a triangular prism, or any prism really, you have your volume formula is just your area of your base times your height. So I want to find the area of my base first, just to be on the safe side. We know that for a triangle, the area of the base is 1/2 the triangle's base times the triangle's height. So 1/2 of 4 is 2, times 2, it looks like this would be 4. And our height here that we're going to work with for the actual prism, the depth, is going to be 8. So this is just going to be 4 times 8, which will just be 32. And there we go. Now there's no units for this one again, so I don't have anything that I can say about that one. Let's go ahead and do one with a sphere. Let's suppose the radius of a sphere is 4 centimeters. We're going to find the volume. Keep in mind, anytime a problem like this pops up that'll be set up for you, you can always pause the video and attempt these on your own. So at this point, you could real quickly just kind of throw that formula down, plug that into a calculator, see what you get. We're going to just take a quick look though. The hardest part for the sphere is just knowing that it's the weirdest of all the formulas. We have 4/3 pi r cubed, which is just a really different, weird looking formula. We see 1/3 show up in a couple other ones, so it's not too far-fetched, but it's still just odd. Having said that, this is one of the easiest things to work with because it has one variable to deal with. The sphere is the only one that I feel is the most straightforward, as long as they're giving you the radius at hand. You would want to look out for the fact that they could give you the diameter as well. So if they do that, just cut it in half like we always do. And then I'll just slide this over real fast. There are a couple of ways in a calculator like this to work with this problem. But if you're not comfortable with some of the mechanics of this, you can just do 4/3 as a division symbol. Now if you're working with a little bit more of a clunkier calculator, you can just do that. We're going to multiply it by pi, and then we're going to multiply it by 4 to the 3rd power. And we're going to get about 268.08. So approximately 268.08. And that's cubic centimeters because it's volume, and they gave us centimeters as our unit of measure. And that would be our volume.